It's a clear day out at sea, with the sun glimmering on the waves and a U.S. Navy destroyer powering through the blue waters on a routine patrol. Suddenly, an unidentified aerial drone appears on the horizon, darting about, performing maneuvers that seem suspicious. But instead of scrambling fighter jets or launching missiles, the Navy crew calmly rotates a sleek turret on deck. A brilliant beam of light erupts from the warship's newly fitted system. Within moments, the target drone bursts into flames or crashes out of the sky, neutralized by a weapon that looks more like science fiction than present-day technology. This is the future of modern naval warfare, and it's no longer just a concept on paper. It's real, it's operational, and it goes by the name HELIOS, a high-energy laser weapon that the U.S. Navy has finally unveiled for the public to see in action. Before we go any further, let's step back and appreciate the significance of this moment. For decades, lasers and directed energy weapons were confined to the realm of imagination, movies, and maybe the occasional advanced research lab with a huge budget and an even bigger secrecy cloak. Many of us grew up watching science fiction films filled with laser guns, towering space warships, and futuristic battles that seemed centuries away. Yet, here we are, bearing witness to the real deal. The U.S. Navy, with extensive support from research institutions and defense contractors, has spent over 2 decades perfecting technology that can use highly focused beams of light to disable or destroy a target. The introduction of the HELIOS system marks a watershed moment, a milestone that indicates directed energy weapons have progressed from test beds to actual deployment. This story, however, is not just about advanced weaponry or supercharged beams of light slicing through the sky. It's also about the evolution of naval power, shifting security paradigms, and how military forces adapt to meet the threats of the 21st century. After all, the modern battlefield is more unpredictable than ever. From stealth aircraft to high-speed drones, swarms of small boats, ballistic missiles, and even potential hypersonic threats, a warship must be ready to counter more dangers now than at any time in history. Traditional projectile-based weaponry can still do the job, but it can be slow, expensive, and sometimes insufficient to deter or neutralize a rapidly evolving threat. A laser weapon, on the other hand, travels at the speed of light, never runs out of ammunition in the conventional sense, and can provide a multifunctional defensive and offensive capability. Once you factor in the lack of recoil, the precision, and the potentially lower per-shot cost, the practicality of laser weapons becomes very compelling to decision-makers in military leadership. I'm excited to take you through the story of how we got here, why the Navy's success with HELIOS is such a giant leap, and what this means for the future of modern warfare. But before we dive in deeper and dissect the technology, the strategic ramifications, and the long-standing research that has finally borne fruit, I want to remind you that this channel thrives on your support. If you're passionate about staying informed on the latest military, tech breakthroughs, developments in defense strategies, and groundbreaking achievements in research, please take a moment to subscribe to this channel. Leave a like if you find this topic as fascinating as we do, and feel free to comment below with your thoughts, questions, or even your predictions about how this technology might shape global security. Your engagement and feedback help us grow and allows us to continue exploring the cutting edge of military science and technology. It's easy to underestimate how incredible the concept of a weaponized laser truly is. We've been culturally conditioned by decades of sci-fi to accept lasers as a normal fixture in futuristic universes, but the technical hurdles in creating a real, effective laser weapon have been monumental. The U.S. military, including the Navy, Air Force, and Army, has tested various forms of directed energy systems for decades. Early prototypes were enormous, unwieldy contraptions that required gargantuan power supplies and cooling systems. They looked nothing like the sleek turret you might see on a modern Navy destroyer. In the past, lasers were typically mounted on large platforms because only an airliner's airframe could carry all the equipment necessary to power and cool the system. Despite the hype, those prototypes generally had limited operational viability. Often they could only fire for short bursts, required perfect weather conditions, or simply didn't produce enough power to reliably destroy even small targets. This reality explains why so many laser programs of the past never moved past the research and development phase. The HELIOS system represents the culmination of improvements in multiple technological areas. Over the last 20 years, the Department of Defense and partnering companies have been refining the science behind solid-state lasers, which use specialized crystal or glass materials doped with ions to generate the high-energy beams. One crucial breakthrough has been the development of fiber lasers, which scale power by combining the beams from multiple fiber laser modules into one concentrated beam. Each fiber laser component has become more efficient at converting electrical energy into concentrated light, and advanced methods of beam combining have enabled power levels to exceed hundreds of kilowatts, an order of magnitude higher than earlier prototypes. Meanwhile, the Navy has invested in robust power generation systems on their destroyers, which can handle the extraordinary energy demands that come with fielding a high-energy laser. These improvements, combined with more efficient cooling systems, advanced targeting sensors, and better beam control software, allow HELIOS to operate effectively in maritime conditions, including humidity, salt spray, and the movement of the ship in rough seas. When discussing HELIOS, it's important to recognize just how integrated it is within the Navy's broader defensive suite. Traditional ship defenses rely on radar, electronic warfare measures, close-in weapon systems, and surface-to-air missiles. Each is specialized to handle specific threats: missiles, aircraft, small boats, or drones. The HELIOS system, however, provides a multi-role solution. Its beam can damage or destroy incoming missiles, scorch or blind enemy sensors, and effectively disable drones or even small boats without the cost and collateral damage associated with conventional munitions. In a sense, HELIOS can offer flexible, graduated responses to threats that might otherwise require a more drastic course of action. When a small suspicious boat approaches, for instance, a laser can be used to send a warning by targeting a portion of the boat without lethal force, or it can escalate quickly to a destructive beam if necessary. Now, what's truly exciting about the Navy's recent announcement is that HELIOS has actually completed a live-fire demonstration in front of the public eye. This demonstration might not appear as dramatic as, say, a missile test that ends in a towering explosion, because a laser's destructive process can be subtle at first. Yet the significance is enormous. The mere fact that the Navy is now confident enough to show the system in action means they believe in its reliability, its readiness, and its potential to be scaled up even further. Years ago, the thought of a fully integrated laser weapon on a destroyer, ready for real-world missions, was almost unimaginable, given the obstacles in power, cooling, targeting, and beam control. Today, we can see the fruits of extensive research, unwavering perseverance, and billions of dollars in defense investment. The strategic ramifications are profound, not just for the U.S., but for militaries around the globe. We live in an era where drones can be purchased at a relatively low cost and repurposed for surveillance or even attack. Swarms of unmanned aerial vehicles can overwhelm conventional defense systems if they come in large enough numbers. With a laser weapon like HELIOS, a warship could, in theory, fire repeatedly at multiple incoming threats without running out of ammunition, limited mainly by power supply and heat dissipation. This revolutionizes how a naval battle might unfold. Instead of carefully rationing missiles or gun ammunition, a ship might simply rotate its laser turret and engage threats one by one at the speed of light with near zero cost per shot, compared to a missile that could cost hundreds of thousands or even millions of dollars. But let's not get ahead of ourselves. While lasers are an impressive breakthrough, they aren't yet a perfect, one-size-fits-all solution. Atmospheric conditions, rain, fog, dust, or aerosolized particulates can weaken a beam. In extremely adverse weather, a laser's effective range might be shortened considerably. Moreover, while the cost per shot of a laser is incredibly low, the system itself, plus the supporting infrastructure, is expensive. It also demands a major power supply, meaning only larger ships or specialized platforms with robust power grids can host a high-energy laser without compromising other crucial shipboard systems. Nonetheless, The progress is undeniably real, and if the challenges of energy storage and beam coherence continue to be tackled effectively, the applications can multiply rapidly. We might see lasers on smaller vessels, land-based vehicles, and even aircraft, if miniaturization continues on its current trend. The U.S. Navy's journey into laser weaponry didn't happen in a vacuum either. The Department of Defense has had a wide portfolio of directed energy projects. The Army has tested ground-based lasers for shooting down mortars and drones. The Air Force has considered mounting lasers on fighter jets for missile defense. The overarching drive has been to counter threats in a cost-effective and precise manner, especially as potential adversaries develop advanced missiles and drone swarms. The unveiling of the HELIOS system is not merely a Navy success. It represents 20-plus years of Department of Defense synergy, with scientists, engineers, and strategists pooling resources and knowledge to conquer technical barriers that once seemed insurmountable. One of the more subtle yet impactful aspects of adopting laser weapons is the psychological effect on both allies and potential adversaries. Seeing a laser demonstration on an operational warship sends a clear message: we've entered a new age of warfare technology. It might prompt adversaries to rethink or recalibrate their tactics or invest heavily in countermeasures. Meanwhile, allies could be reassured that the U.S. Navy is at the forefront of innovative defense, potentially strengthening alliances and cooperative defense initiatives. This technology also acts as a catalyst for an arms race in directed energy weapons. Other nations with significant defense budgets, such as Russia and China, have also been vocal about developing their own high-energy laser systems. Even if they are behind, announcements like these serve as motivation to close the gap as quickly as possible. That said, the question often arises: how reliable is HELIOS in a real combat scenario? It's a valid concern. Testing against drones and dummy targets in controlled or semi-controlled environments is one thing. Engaging a swarm of live, unpredictable threats during an intense naval conflict is another. But the Navy appears committed to thorough testing and incremental implementation. The fact that HELIOS is being deployed on an actual destroyer suggests that the system has passed rigorous trials in labs, test ranges, and at sea. The next steps will likely involve more complex drills, engagements, and scenarios to refine the system's performance and reliability. Over time, the Navy will gather valuable data on how the laser performs in variable conditions and refine the system's targeting and power management accordingly. On the broader horizon, the introduction of HELIOS and other laser weapon systems begs us to re-examine the fundamental doctrines of naval warfare. Historically, a warship's might was gauged by the caliber and range of its guns, the sophistication of its missiles, and the presence of advanced sensor arrays. Now, a new metric might come into play: the power rating of its directed energy weapon. In future conflicts, the ability to disrupt or destroy an inbound threat with a laser could mean the difference between survival and destruction for a naval vessel. As lasers scale up in power and reliability, one can imagine them taking on roles once reserved for large missile systems. If you can neutralize an incoming missile with a shot of light, you might not need to launch your own missile worth millions of dollars. The cost savings and logistical simplifications here are immense, not to mention the potential for drastically improved operational endurance. Another compelling aspect of laser weapons is their potential in defensive roles that go beyond physical destruction of incoming projectiles. High-energy lasers can potentially disable or dazzle enemy sensors, cameras, or other intelligence-gathering equipment without creating an explosion or giving away a massive signature. This ability to selectively neutralize an adversary's capabilities while minimizing collateral damage aligns well with emerging doctrines that emphasize precision, surgical strikes, and the avoidance of unnecessary destruction. As the technology matures, we might see even more refined ways to adjust the intensity of the beam so that it only temporarily blinds sensors or heats up external systems, causing a shutdown rather than a catastrophic explosion. Let's talk a bit about how HELIOS fits onto the Navy destroyer. Typically, a modern U.S. Navy destroyer is powered by gas turbines, which generate electricity for the ship's electronics, propulsion, radar, and other systems. Integrating HELIOS means the ship needs sufficient excess power capacity to charge the laser's capacitors and feed the beam. This is no trivial task, as many existing warships were not designed with high-energy lasers in mind. Engineers and naval architects had to ensure that the ship's power distribution could handle the spikes in demand that come from firing the laser at high power. They also had to install advanced cooling systems to prevent the laser and its components from overheating. The fact that HELIOS is now operational suggests that these engineering challenges have been deftly managed, which is no small feat. It also implies that future classes of warships might be built from the ground up with directed energy weapons as a key design consideration, possibly leading to more streamlined and powerful lasers on board. Another intriguing angle is how HELIOS and similar systems will integrate with other elements of a ship's combat information center. Modern naval vessels rely heavily on advanced radar and sensor fusion to detect, track, and classify threats. The laser weapon would presumably tie into that same network, receiving precise targeting data on an incoming drone or missile. The weapon operators, or in some cases, the ship's automated defense system, would then decide if and when to engage. One can imagine a near-future scenario where multiple drones approach from different angles, and the ship's sensors automatically cue the laser to engage the most immediate threats first, then move on to the next, all within seconds. This kind of automation isn't just a convenience, it's crucial when you're dealing with high-speed and potentially numerous threats. The synergy of high-energy lasers, advanced radar, and automated targeting could significantly change the dynamics of naval engagements. As we reflect on the significance of this new era in weaponry, it's important to keep in mind that none of these developments occur in a vacuum. International treaties, laws of war, and ethical considerations will all come into play. The idea of a directed energy arms race might raise concerns about proliferation and misuse, just as nuclear weapons did in the mid-20th century. However, the trajectory of military technology tends to move forward relentlessly, driven by the constant push to maintain a competitive edge and deter adversaries. Directed energy weapons like HELIOS are quickly moving from a novelty to a cornerstone of modern military strategies, and their presence on the geopolitical stage is likely to expand as more nations either develop or acquire similar technology. Now, to put this in context, the U.S. Navy's progression toward fielding lasers did not happen overnight. The Navy's research labs, in conjunction with private defense contractors, have tested prototypes and smaller-scale versions of laser systems on various ships for several years. Some of you might recall earlier demonstrations of what was then called the LAWS, Laser Weapon System, tested on the USS Ponce in the Persian Gulf around 2014. That was a lower-power system with limited range and destructive capability compared to HELIOS, but it provided invaluable data on how lasers function in marine environments. Essentially, the LAWS project served as a stepping stone, proving that lasers could indeed operate effectively in the salty, humid conditions at sea. From that foundation, the Navy ramped up power, improved beam quality, and integrated advanced targeting, culminating in HELIOS. Given how crucial maritime superiority is to U.S. global defense strategy, the successful deployment of HELIOS marks a major step forward in ensuring that superiority endures. Aircraft carriers, destroyers, cruisers, and future frigates could all eventually carry versions of directed energy systems. This layered defense approach provides a more robust shield against the growing variety of threats. If a warship can deal with cheap drone swarms using a nearly limitless supply of laser shots, it frees up more expensive, limited missiles for larger, more sophisticated threats. From a budgeting standpoint, this is a dream scenario for naval planners who are constantly trying to balance cost, capability, and readiness. We've covered a lot of ground, but I want to emphasize just how significant it is for the U.S. Navy to show off HELIOS in a public demonstration. The military rarely reveals its hand unless it sees a strategic advantage or necessity in doing so. In this case, it sends a strong message of deterrence. It states that the U.S. Navy isn't merely experimenting with laser weapons. It has them, they're operational, and they can and will be used if circumstances demand. For anyone observing from the sidelines, be they potential adversaries or curious onlookers, this demonstration underscores that the future of warfare has arrived. And that future is centered around technologies that once seemed purely fictional: lasers, railguns, unmanned systems, artificial intelligence-driven decision-making, and more. Each new breakthrough redefines what's possible in both defense and offense, raising the stakes in international security competition. As you think about these developments, imagine what the next few decades might bring. With advances in battery technology, nuclear fusion research, or more efficient forms of energy generation, the power constraints that currently limit lasers might become a non-issue. We might see smaller vessels equipped with scaled-down versions of HELIOS, or even more powerful lasers that can take out supersonic missiles at greater distances. We could also see multi-spectral lasers that can cycle through different wavelengths to optimize for atmospheric conditions, or advanced adaptive optics that compensate for turbulence and particulate interference in real time. The synergy of these technologies might make the modern battlefield nearly unrecognizable compared to what we see today. And yet HELIOS is the first big step that proves directed energy weapons are not just around the corner, they are here. All of this excites not just military historians and tech enthusiasts, but also policymakers and strategists who constantly look for ways to protect assets and maintain a competitive edge. Beyond the U.S. Navy, we could see a ripple effect across all branches of the military, each adopting or adapting directed energy solutions for their domains. The Army could deploy lasers on vehicles to protect ground troops from drone attacks. The Air Force might install lasers on large aircraft to protect against incoming missiles. Such scenarios may dramatically shift the design and composition of the armed forces, prompting debates about how to train personnel, allocate budgets, and coordinate joint operations when high-energy lasers are a staple of battlefield engagements. Now, as fascinating as all this is, it's also essential to engage with the topic critically. Technological leaps in weaponry bring moral and ethical questions. How do we ensure these powerful systems are used responsibly? What happens when multiple adversaries possess lasers of similar or greater power? Could there be unintended consequences, such as accidental blinding of satellites or escalation of conflicts, when a ship uses a laser in what it considers self-defense? These questions may not have straightforward answers, but they're worth keeping in mind as directed energy weapons become more commonplace. It's part of the broader discussion about how humanity navigates the line between innovation and regulation, especially in the realm of military technology. At this point, we've only scratched the surface of what HELIOS and similar systems can do. If you've stayed with me through this journey, I want to thank you for taking the time to delve into the intricacies of the U.S. Navy's newest operational laser weapon. The development of HELIOS is more than a technological showcase. It's a testament to human ingenuity, to the collective drive to push boundaries and shape the future of warfare and defense. And while we can marvel at the achievement, we should also remain informed and engaged with the broader implications. The arms race in this area is likely to intensify. Allies, adversaries, and neutral parties will be watching closely to see how the United States integrates this capability and how effective it proves in real-world conditions. As we close, picture the destroyer out there on the open ocean, scanning the horizon with its advanced sensors. Picture that sleek turret with the HELIOS system, silently ready to fire a beam of light at the speed of light. No dramatic fireworks, no thunderous recoil, just a focused shaft of energy capable of changing the face of naval combat. It's a moment that signals not only a new chapter for the U.S. Navy, but quite possibly a new era for militaries worldwide. The leaps made over the last 2 decades show us that the line between science fiction and reality can blur more quickly than we ever imagined. And as laser weapon technology continues to advance, we can only guess how future battles might be fought. Whether for deterrence, defense, or active combat, HELIOS is now front and center, reminding us that tomorrow's arsenal is being shaped today. Thank you for joining me for this comprehensive overview. I hope you've learned something new about this fascinating breakthrough. If you enjoyed this deep dive, make sure you're subscribed and that you've left a like and a comment. Let's keep the conversation going. And as always, stay curious, stay informed, and I'll catch you in the next episode.